Is Ido. Ido, you are welcome to share your slides.
Okay, you see it okay?
Yes.
Okay, this paper was conducted with my ex-student Eyal Ert, Uri Plonsky, and Yafim Roth. And it's part from a long project that was inspired by an open question posed by Kalman Tversky. Kalman Tversky wrote in the classical analysis that highly unlikely events are either neglected or overweighted. That is, they left the task of predicting the impact of rare event to future research. Our previous research that tried to address this open question show that this question can be addressed by focusing on the impact of experience. In particular, we found that people tend to overweight rare event when they make decision from description, like the situation examined experimentally by Kalman Tversky. But once they start getting feedback, even when they have full description of the choice task, this feedback reverses its bias and lead them to behave as if they neglect the rare event or behave as if it won't happen to me. Here is one example from a recent paper. In this study, the subject were asked to choose between a loss of 1 shekel with certainty or a gamble that gives them a 5% chance to lose 20 and 0 otherwise. The subjects receive full description of the task, and when they first respond, before they got feedback, they tend to avoid the gamble. That is, only 48% selected the gamble. But once they start getting feedback, after 3 trials already, most of them end up preferring the risky gamble as if they neglect or underweight the rare event, the 5% event, to lose 20. The current paper extends this investigation by clarifying the impact of experience on the phenomena captured by prospect theory. The starting point of the current analysis is the observation that the main effect of experience can be captured with the assumption that people tend to select the option that led to the best average outcome in similar situation in the past. To clarify this assumption, think what you would do in trial 16 of the current experiment. In each trial in this experiment, you are asked to choose between top and bottom. And this table here presents the outcome in the first 15 trials. And as you can see, in bottom, in all previous 15 trials, always led to a pair of zeros, that is, maintain the status quo. In contrast, top led to the pair of -1, -1, -1, then in trial 4, +2, then -1, -1, and then trial 8, +2. So what would you do in trial 16? Now, unless, under the assumption that you have not taught statistics for too long, and if you behave like our subject, you would go for up in trial 16. And the reason why you would do that, and this is what the typical subject do, because say, hey, notice here a pattern, like every 3 times, a +2 comes. Now, this attempt to find patterns amounts, basically, although they had 15 previous trials, what they do is they base a decision in trial 16 only on 3 previous trials, only in the pink trial. Because say, oh, well, trial 16 is similar to the pink trial, I don't have to worry about all the rest. When the environment is dynamic, for example, if the environment is Markov chain, this strategy of looking for a similarity-based pattern approximates the optimal strategy. However, when the environment is static, this tendency to rely on small sample can lead to deviation from maximization. Our main assumption, or our results suggest, that people behave as if they try to rely to detect pattern even when we tell them that the environment is static. And we believe that the reason why they do that, because most real-life situations are patterns, are not static situations. The present paper clarifies the implication of this small sample hypothesis by focusing on 2 observations. The first one states that reliance on small sample imply a bimodal reaction to rare events. A recent and important example of that is the coexistence of panic and it won't happen to me reaction to COVID-19. The second observation that we will try to clarify is the existence of non-monotonic risk and loss attitude. One example for that is the observation that many people underinvest in the stock market that is behaving as if they are loss averse, but the same people, some of them take loans in order to buy expensive homes, and they take more risks than just investing in the stock market. So we try to eliminate these two observations. Our analysis focuses on a very simple experimental paradigm. What you see here is all the instructions the subject gets. Basically, they come to the lab and we tell them the content experiment includes many trials. Your task in each trial to select on one or two keys. Once you press on the keys, you get some payoff. This is your payoff. We will pay you for one randomly selected trial. So for example, the subject select trial number 1 right, and then he gets a payoff as a feedback. You selected right. Your payoff in this trial is 1. We also tell them, had you selected left, your payoff would be 0. So there is no reason to explore here. And then the subject select again, say right again, and gets this feedback. Notice this paradigm, that unlike the paradigm considered by Ilke earlier in this meeting, there is no, in this paradigm, there's no sampling stage. Basically, in our experiment, there is one sequence of 100 trials, and we pay for one randomly selected trial. So there's no sampling stage here. And here are the main results. The first phenomena I want to demonstrate is a bimodal reaction to rare events. The two experiments on the screen illustrate underweighting of rare events. In this problem, the dark problem, the subject have to choose between 0 for sure and a bad lottery, a lottery with a negative expected value, -10 with probability 0.1, +1 otherwise. The subject in our experiment in the first 20 trials, this is block of 20 trials, so it's 100 trials. The first 20 trials, they select the bad lottery 20%, 70% of the time. And with experience, they move toward maximization, but very slowly. And after 100 trials, they still select it 60% of the time. The reliance on small sample model reproduces results. The reason why it reproduces it, well, this model is with a parameter relying on average sample of size 5. If you rely on sample of size 5, in 60% of the time, the sample will not include the -10 outcome. So in 60% of the samples, option B, the bad lottery, looks better. So this is how the model reproduces results. The light problem shows that the same thing happens when the lottery is a long shot, gamble 10% to win 0.1. So we have near symmetry here, and the reliance on small sample model reproduces results. Yet the reliance on small sample also says that a significant minority of the choices will reflect overweighting of rare event. To clarify this point, think about this trivial choice task, 11 for sure or 12 for sure. So in this case, subjects are not stupid, so they learn very quickly to avoid the 11 for sure, they prefer 12 for sure. So only 5% select the 11. Now, if we replace the 11 for sure with a lottery with expected value of 11, but that provide 20 probability 0.1, then otherwise, so the choice rate of this bad prospect go up from 5% to 20%. That is 20% choices reflect overweighting of rare event. And the reliance on small sample exhibits similar tendency. The second set of phenomena that I want to present, which I think this may be the first time you see it, is the existence of non-monotonic loss or risk attitude. Look at this experiment here. The subject in this experiment are asked to choose between a safe prospect that maintains the status quo, provides 0 for sure, or two risky lotteries. One provide +4 or -4, almost 50-50. The other one provide +8 or -8, almost 50-50. Now, if you only compare the safe prospect with a medium risk prospect, the + or -4, you will see a loss aversion pattern. The subject prefers the 0 for sure over the gambles that provide 4 or -4. However, the proportion, they like the +8, -8 more. Okay, so here they don't exhibit loss aversion. In this task, the two lotteries are perfectly positively correlated. If you reduce the correlation, then you get a bias against loss aversion. Here is an extreme example. Here's the two lotteries are negatively correlated. Here you have +4, -4, or -8, +8, both of them with probability 0.5, or 0 for sure. What you see here, that even after 100 trials, the subject really don't like the safe prospect. They select it only 15% of the time. Notice that both patterns here are captured by the reliance on small sample without adding anything. In this case, the reliance of the top example, the reliance of some small sample don't choose the reliance of small sample model implies avoiding the +4 -4 because the +4 number because of the two gambles are positive correlated. The two gambles, this prospect is never the best. If you rely on small sample, you never get a sample in which the +4 -4 is the best. Here, because the two lotteries are negatively correlated, then the 0 is never best. One of the two lotteries is always best, and this is how the small sample model predicts. It doesn't predict 0 because the model also has some error rate. Okay, so these were the main experimental results I wanted to present, and now I want to try to convince you that these experimental results are not just interesting, funny findings that can find in my unique paradigm, but this is something we see in real life. So I want to talk about two well-known empirical phenomena. Let's talk first about the observations that many people buy lotteries. The common explanation under prospect theory is that people buy lotteries because they overweight rare event. But this explanation ignores the fact that most of us don't buy lottery very often. Even people who tend to buy lottery don't buy in each opportunities that they have. Most people buy less than once a month. Now, the small sample model captures this finding. We only buy lottery when we feel lucky. And that is when the long shot outcome is in our sample. But this happens rarely. So people buy lottery, but this doesn't mean that they like to buy lottery all the time. The second phenomenon I want to present here is, as I already mentioned, is the explanation for underinvestment in the stock market. The common explanation for underinvestment in the stock market is that people are loss averse, and for that reason they don't like stock, the high variability. However, this explanation ignores the fact that many of the people that don't buy stock, don't enter the stock market, actually take risky loans to buy their own home, and this is higher risk. The reliance of small sample model explains this phenomena too, this pattern too, because investing in stock is similar to the +4 -4 prospect. It's almost never best. In countries like Israel, at least, the real estate always go faster than the apartment most of the time. Of course, there could be crash, but when they're crashed, it's better not to buy anything, not stock or homes. So this is how we explain this phenomenon. Importantly, the small sample hypothesis is not just a post hoc explanation of the current results. We ran, as I hope you know, several choice prediction competition, at least 4 competitions that focus on the impact of experience. And in all 4 competitions, the best models, the winner, the basic idea behind all the winners were reliance on small samples. Okay, so the current effort to clarify the impact of experience on the phenomena captured by prospect theory highlight 3 main observations. The first is that this impact of experience is large, replicable, and non-trivial. It is not true that experience always leads people to maximize. Rather, in many situations, experience lead to a reversal of the prospect theory phenomenon. For example, people start with overweighting of rare event. Once they get experience, they behave as if it won't happen to me. 2, despite this complexity, the impact of experience can be predicted with a simple and ecologically reasonable reliance on small sample hypothesis. This hypothesis is ecological reasonable because it approximates the optimal strategy in a dynamic world. The last observation is that the small sample hypothesis imply a very different biases and cognitive processes, and the biases and cognitive processes implied by the common interpretation of prospect theory. I would like to conclude by presenting my interpretation of the contribution of prospect theory. I think prospect theory was highly influential and had very good positive effect, but my interpretation is different than the typical interpretation. I would like to think about research as hiking in the land of assumption, this area here, this is a topographical map, hypothetical topographic map of the land of assumption. And what we try to do when we walk around, when we hike in the land of assumption, is to try to find high hills, that is nice model from which we can look and see interesting phenomena in the land of problems. Okay, so we try to hike. And I think prospect theory had three important contributions. The first contribution is to show the relationship between basic research in economic and basic research in psychology. And basically with prospect theory, we could see there is a connection between expected value, expected utility models and basic research in psychology. So prospect theory captured basic idea in psychology by adding it to the research in economics. Then what the basic research on prospect theory did was providing a good map of this hill of assumption and finding a highest point on that hill for which we can see phenomena that we didn't know before. And I think that was very important. Yet the third contribution and the main and the things that that trigger my research is that even in the first paper, Kalman Tversky note that it's very difficult from the prospect theory hill to see why people sometimes overweight and sometimes underweight rare event. And 50 years of research, they left it as an open question, but 50 years of research could not find a point on this hill from which we can explain this phenomena. So I think the third contribution and all the nice research conducted in recent years and the nice analysis summary of Peter Wacker show that maybe we should consider the option of changing some of the assumption and moving to a different hill. Maybe this hill of assumption in which we assume reliance on small sample can help us see better and predict human behavior. This is basically.
Thank you very much, Ido. Thank you very much, Ido. We will have the opportunity to have more of your view on prospect theory later in the roundtable. Thank you very much.
Thank you.
Well, I am the next speaker.